All right, go ahead and take out your homework and turn your textbooks to page 243. Page 243. We're talking about circles, or have been lately. Talking about the area of a circle, talking about the circumference of a circle. Of course, circumference is to a circle what blank is to a polygon. Perimeter, right. Circumference, perimeter, they're pretty much the same thing. Just one refers to a circle, the other to polygons. And then area, of course, Lana, always refers to that which is inside an enclosed figure. There we go. Of course, area is always measured in what kind of units, class? Square units. Good, Lana. And circumference, like perimeter, just be in normal inches or feet or what have you. The circumference of a circle, the distance around a circle, always is related to the diameter, and it gives a constant value if you divide it. If you make a ratio, if you will, of circumference to diameter, it always comes out the same. Lana? Take the ratio of the circumference of a circle to the same circle's diameter.
Circumference over diameter.
Right. What is that ratio?
Pi.
Pi. It always comes out the same. It always comes out as pi. So we get that relationship there. Several parts to a circle that were reviewed here in the homework that you did. Good, 1 through 15. They're on page 243. Number 1, they asked you, what is this line called from A to B? It goes from one side of the circle, ends on the other side, and it passes through the center. It's called a diameter. Good. Number 2, from N, the center of the circle. By the way, we would name the circle, circle N. A circle is named by its center point. But from N to point C on the circle, Lana, is called a radius. How does a radius compare to a diameter, class?
It's only half equal one diameter.
Okay, you can say 2 radii equals a diameter, or it's half of a diameter, correct? What kind of angle is angle CNB, Scott?
Central angle.
A central angle, as they're at the center formed by 2 radii. What is point N? We already addressed this, sorry.
Center.
The center, right? What about BC, Lana, staying with you? That little portion of the circle, that little curved piece.
Arc. I just put arc.
Good, it's an arc, arc BC, good. What about the line from A to C, starting and stopping on the circle?
Chord.
So is a diameter a chord?
No. Yes.
Yes, a diameter is a special chord. It's a chord that happens to go through the center. What about the arc from A all the way around to B, Lana?
Semicircle.
Good, more specifically, that's a semicircle. What about the area enclosed by the angle CNB and the arc BC at the end of the central angle?
Sector.
Called a sector of a circle. Very good. Any questions on those terms 1 through 8? All right, what are our equations then? You had to find circumference and area. For circumference, we actually have 2 different equations, Lana.
Pi d and 2 pi r.
Good, pi times diameter, or 2 times pi times the radius, which, again, 2 radii equals a diameter. So do you really need 2 equations? Probably not, but whatever. It's not that hard to memorize. And then what was our equation for the area of a circle, Scott?
Pi r squared.
Pi r squared. And we'll skip the lame joke I usually go with that one. All right, so if the radius is 20 inches, what do you get for the circumference, Scott?
125.6.
Approximately 125.6 inches would be correct. What about for the area?
1.256 square inches.
Lana, what did you get for the area on number 9?
1,256.
Approximately 1,256, because if the radius is 20, you're going to square that to get 400 times, what was our estimate value for pi here, Scott? Pi is approximately 3.14, or we could also, what's another value we could use that's approximate there if we had fractions or something, Lana? Scott? 22 sevenths.
Oh.
Either one of these would work, 3 and 1/7, because 1/7 starts out 0.14, blah, blah, blah. But yeah, either 22 sevenths or 3.14. In this case, the sevenths thing doesn't really help us. I wouldn't go with that. Now, on number 11, 21. That would be divisible by 7, wouldn't it? So I'm going to use the 22 sevenths on number 11 instead of the 3.14. That's going to make my life easier. Number 10, Lana, you had a diameter of 11 feet. What was your circumference?
Approximately 34.54 feet.
Good, and I like that you included the word approximately. Approximately 34.54 feet. What about your area? Back to Scott for redemption.
94.985 square feet.
Good, approximately 94.985 square feet. Now, let me ask, before we do number 11, did either of you use 22/7?
No.
You both used 3.14. All right, Lana, what did you get for the circumference?
131.88 centimeters.
Approximately 131.88 centimeters. Okay. What about the area, Lana?
1,384.74 square centimeters.
Okay, approximately 1,384.74 square centimeters. I want to show it with the 22/7 here. Circumference equals 2 pi r, which is 2 over 1 times 22 over 7 times a radius of 21 centimeters. If you cancel the 21 and 7 to get 1 and 3, well, 2 times 22 is 44, times 3 is 132 centimeters. Do you see how easy that was? Now, it's slightly different from your answer. You said you had 131.88, slightly different, right? But it's an approximation anyway. You're already going to say approximately 132, approximately 131.88, so it doesn't really matter. And then for the pi r squared, that's again 22/7 times 21 squared, or you could say times 21 times 21. Well, the 7 cancels with one of the 21s to get you the 1 and 3. That gives you 66 times the 21, 1,386, which you said 1,384.74. Well, again, it's approximate, okay? And it just is so much easier, right? So anytime the number they give you is divisible by a 7, go with the 22/7. Make your life easier. Okay, that's part of being a mathematician, is being lazy and finding shortcuts. So anyway, wanted to point that out to you. Number 12, find the area of the top of a circular bottle cap that has a diameter of 4 centimeters. Scott?
12.56 square centimeters.
Good, or centimeters squared. Technically, remember, metric units aren't SQ, square centimeters. No, it'd have to be centimeters squared, where square feet, that's okay. Feet squared, that's okay. So English units or US units, either one. Metric units always use the square. Now, I'm lazy, right? SQ takes longer to write than an exponent of 2. Plus, I have to remember which one's which. No, I don't. I just always go with the exponent. So just tuck that thought away again. Mathematicians are that lazy, finding those shortcuts. Number 13, give the formula for each of the following. Letter A, Lana, perimeter of a square.
E equals 4s.
Good. Letter B, area of a parallelogram.
A equals B.
Good. Letter C, area of a trapezoid.
A equals 1/2 h times the quantity of v1 plus v2.
Very good. I like that you use times the quantity of. Excellent job. Well worded. You are on your way toward becoming a mathematician. Letter D, Scott.
B equals 12 plus 2w.
Excellent. Letter E, Lana.
A equals 1/2 bh.
Good. And letter F.
A equals x squared.
Excellent job. Number 14, taking a total break from all things geometry. This has nothing to do with geometry, just solving some inequalities. Letter A, what did you get for your inequality answer, Lana?
X is greater than or equal to -2.
Great job. Remember, when you divide by that negative, you have to flip the inequality. X is greater than or equal to -2. Letter B, Scott.
2 is not equal to 5.
Yeah, there it really doesn't matter, right? I mean, because you can't flip an unequal sign, can you? So y is not equal to +2. You can't flip a not equal. So y is not equal to 2. And then for letter C, let's stay with Scott.
-4 is less than or equal to x, which is less than
-4 is less than or equal to x is less than -2. Great job with the turnaround there. Did you also get it? Good job on that as well, Josh. Hopefully you did as well. By the way, looking forward to having you back next week. So just 4 more of these video lessons, and hopefully Monday we'll get you back with us there. But trust you're starting to feel better. Number 15, match each inequality with the problem solved in number 14 with its graph. So letter A, which one is x is greater than or equal to -2? Class?
E.
Graph E. For part B, it was y is not equal to 2. Which one is that?
C.
That should be letter C. And then which one is -4 is less than or equal to x is less than -2?
D.
D.
Letter D is correct. So E, C, D, your answers for number 15. All right, any questions on the homework? All right, let's practice a little bit more with circumference and area. Look right across the page, page 242. I want you to do numbers 11, 13, 17, 19, 22, 25, and 27. So 7 problems for classwork on the previous page, page 242. And take about 4 minutes, work as quickly as you can. See if you can get all of them done. And try to strategically pick. If you're given the choice, 3.14 or 22/7, I'll allow you to deviate from their instructions if you feel it would be better to use the fraction. So take a few minutes to work on these. And no, I'm not going to play thinking music, sorry. Joshua wouldn't understand. Oh, no, can't. No, it's not his fault, he's out. The music's probably copyrighted anyway, and I get flagged up for a YouTube violation if I played it on video. That's probably what would happen. Then Miss Morse got flagged. She showed y'all video or something in science class, and YouTube dinged her account, says you can't show copyrighted videos on a YouTube video. So, yeah. for sake of time, let's go ahead and stop where we're at. Take a look at these and see how we did. Let's start with number 11. And Scott, we'll start with you. What did you get for the circumference?
10.99 yards.
Good, you could have gotten 10.99 yards, or maybe you got exactly 11 yards. Did you get 10.9 or 11?
10.9.
How could you have gotten exactly 11?
22,
3.5 is 7 halves. Pi times diameter takes this diameter times pi. Isn't that easier? That's where a mathematician's brain works, right? The book doesn't have that because they were expecting you to use 3.14, but the mathematician sees shortcuts and saves time and effort. Now you couldn't do that on number 33. Or number 13, excuse me. What did you get for number 13, Lana?
15.7 feet.
Good, approximately 15.7 feet. Nor on number, oh, you didn't do 15. On number 17, wouldn't have really helped you there either, Scott.
113.04 millimeters squared.
Good, approximately 113.04 millimeters squared. On number 19, Lana, still got to use the 3.14.
50.24 inches squared.
Good, 50.24 inches squared. Number 22, you were supposed to find first the circumference, then the area, and they look a lot alike. What'd you get for the circumference, Scott?
1.256 meters.
Good, 1.256 meters, and for the area you had?
1.256 meters.
No.
I got 0.1256.
0.1256 meters squared. Keep in mind, 0.2, when you multiply by 2, so 2 times pi times r, versus pi times r squared is going to have one extra decimal point in it, isn't it? So be careful with the decimal. Yeah, so 1.256 meters for circumference, 0.1256 meters squared for the area. And number 25, 70. And they even tell you in the directions to use the 22/7. Lana, what's the circumference?
Oh, please. I didn't finish that one.
Okay, well, let's do it very quickly. They give you a radius, so we want to use the equation C equals
2 times 22/7 times 70.
there we go. And we'll put the 70 over 1 to 22 over 1. We'll cancel the 7 and 70 to get
1 and 10.
10. There we go, of course, 1. And then 2 times 22.
22.
2 times
Oh,
22.
44.
44 times 10.
440.
There we go. Approximately 440 meters. There we go. And then for the pi r squared, we're going to have 70 over 1 and then another 70 over 1, correct? So multiplying the 70 twice. Of course, one time you can cancel to get the 1 and 10, right? And 10 times 70, let's do that first.
700.
700. And I'm going to slide the 2 zeros off to the side here. Just copy them down. 7 times 2.
14. 15.
There we go. So 1,000 or 15,400 meters squared should have been our area for number 25. Number 27, Scott, the radio station WPCS can be heard clearly for 50 miles in all directions from its transmitter. How many square miles does the station serve? Did not get that one?
I didn't.
What's 50 miles in all directions mean? That's a 50 miles in all directions. So here's the transmitter, right? Okay, and then 50 miles in all directions. 50 is the
Circumference. Oh, wait.
radius. So how would I find how many square miles the station can serve?
Pi r squared.
There we go. A equals pi r squared. Find it very quickly. Call it out when you've got it. Find it very quickly. Call it out when you've got it.
I need to finish it.
I figured out which kid thinks it's water bottle full.
Oh.
Mr. McDonald's.
You have to tell them sometime that while you're trying to get your homework done for history class, keep hearing him banging a water bottle. One time you saw the
7,850.
There we go, 7,850 square miles approximately should be our answer for 27. Good job on that, Lana. What happened to you? 50 squared, 2,500 times the 3.14. All right, look over now at page 244. Turn the page, page 244. Answer numbers 1 through 9. So 1 through 6, write out the formulas. 7, 8, 9, using formulas to find the areas of each of those polygons. Do numbers 1 through 9 on page 244. Lana, and it's Scott. All right, number 1, the formula for the area of the parallelogram, Lana.
A equals BH.
Area of a circle, Scott.
Equals pi r squared.
Good, area of a trapezoid.
A equals 1/2 H times the quantity of B1 plus B2.
See, I feel like you answered the same one for homework. Area of a triangle, Scott.
A equals 1/2 times BH.
There we go. Circumference of a circle, Lana.
C equals pi d or C equals 2 pi r.
And area of a square.
A equals a squared.
Good, number 7. What was the area of that rectangle, Lana?
500 square yards.
Excellent, 500 square yards or yards squared. Now, number 8, you notice the height or the altitude lies outside the triangle. That's okay. You're measuring from the top down to the base, perpendicular. What is the area, Scott?
112 inches squared.
No, 164.
Yeah, carefully. When you're going to use the 1/2 base times altitude, I'm going to do the 1/2 20.5 times 16. And the easy way to do that, Scott, knock the 16 in half with an 8. And then when you multiply the 8, that's where you get the 164.0 or 164 square inches. Figure out what you did? All right. I'll tell you what, for redemption, number 9, the area of the trapezoid.
25 meters squared.
25 meters squared is correct. Good to go on that one. All right, questions on the 1 through 9? All right. want you to work on number 10 now. Find the area of that complex figure. You're going to need to use, what do we call those lines we draw to help?
Adjacent.
Auxiliary.
Good, auxiliary line. So you're going to want to use at least one, probably just one, auxiliary line to complete this problem. So solve number 10 at your seats. Pencil down when you've got it.
Do you just add them up at the end?
Right, you just add the areas together once you've got it. Lana, which auxiliary line did you draw? Did you draw a vertical, did you draw a horizontal, or did you draw both?
Horizontal.
Just a horizontal, okay? All right, so that means, Lana, that this little rectangle here has the dimensions.
24 by 28.
Right, and you multiply 24 by 28 to get what? It's 672 square yards. All right, but that means we have to finish solving the rest of this. And this is a very big, long rectangle, isn't it? How long is the rectangle, Lana?
38.
Oh, just this much is 38.
I was confused by that.
So if this much is 38, that means the whole thing has to be longer than 38, right? How long is it, Scott? It's got to have a length of 62 because here's 24 length here, right? And there's 38 length here, so where the 38 stops, the 24 begins. Total length 62. We also need to know how tall is this rectangle here. Well, we know this whole height is 47, but 28 of that is right here. So that leaves what height remaining across here, Lana?
23.5. That's what I got. Half of 47.
Okay, it's not necessarily half though, Lana. It doesn't cut it in half. It breaks into a piece that's 28 and a piece that is, Scott, 19. So 19 and 28 for the whole 47. So we end up with a 62 by 19 rectangle here. And what do we get for our insert here, Scott? You drew the vertical line? The vertical line actually makes the numbers work just a little bit easier, actually. All right, let's multiply real quick. 62 by 19. Lana, 9 times 2?
18. 55.
And of course, 1 times 62.
62.
And we add them all together, and we get
1,178.
there we go. And then we have to add these two numbers together. So the 1178 to the 672, and we end up with
1,850.
1,850 square yards. Is that what you had? Excellent. Now, showing it with the other auxiliary line, a little bit less extra math, I think, if you use the other auxiliary line. So let me show that one, because again, there's more than one way to work the problem. If you draw this line instead of vertical, you already know you have a 47 by 24. So you just multiply that to get 1128. And you know this is 38, you just had to figure out the height still, which you had to find the 19, right? And you found this area to be
722.
and you still add it together and get the 1,850 square yards. All right, questions on that problem? All right, number 11 now, another unusual looking shape. Though we've seen this shape before, I would recommend just 2 auxiliary lines, not 4. You could draw 4, but I would recommend 2 instead of 4. Or you could extend it all the way around and cut out the corners. All right, your choice. All right, Scott, which 2 auxiliary lines, or did you draw 4? You drew 2, right?
No, I drew the outside.
You did the outside. You took my perimeter suggestion. All right, so you kind of extended it all the way out then. All right, so this is one way to do it. I'm not sure if this is even the best way, but it's an entertaining thought. All right, if you look at it this way, Scott, then you have to realize that the entire base is actually 11, and the entire height is 9. So that means the whole thing, if you extend it out to a great big rectangle, has a mass area of 99 square whatevers, right? Inches squared, right? But there's a little 2x2 pocket in every corner, right? And each 2x2 gives you an area of, that you have to take away from that. So there's 4, 8, 12, 16 you have to take away to give you an area of 83 inches squared. And that's one way to do it. I think the math works pretty easily that way. Now, Lana, you took my initial suggestion, which probably is the more conventional approach, and that was to draw 2 lines, and you do 2 lines that were
like
horizontal. Okay, so you do the 2 horizontals. It's either that or the verticals, and I don't know that there's an advantage either way.
I got the wrong answer anyway.
Oh, okay. Well, let's see if we can figure out why. The top rectangle, Lana, has what dimensions?
I got 7x2.
It is 7x2, and that's an area of
14.
And the bottom one is also going to be 7x2, so it's also going to have
14.
14. Now, here's where it gets dicey. What are the dimensions of the big middle rectangle? Obviously, this dimension is 5 by...
I got 7 by...
But it should have been...
14.
Ooh.
28.
You have a little 2, you have a 7, and you got a 2. All added together.
Oh, 11.
11, right? There's 2, then 7 more, then 2 more. So it's a 5 by 11, which is 55. And we should have added 14, 55, and 14 together to get it. Could have also, as an alternative, drawn this to get 10 on the sides, and a 7 by 9, which is 63. So 10, 10, and 63 also would have given you 83 square inches. Does it make sense now? All right, number 12. You've got a great big class trapezoid, but there's a hole in the shape of a
Square.
rectangle, not quite a square, but a rectangle that you'd have to subtract away. Do number 12. So Scott, what jersey are you wearing? Lionel Messi. Okay. I thought it looked like it was Barcelona, right? Yeah. It looked like Barcelona. It's like, that would be Messi, but, and it just finally hit me as I was asking the question his first name was, okay, there's the L. It's like, Barcelona, Messi. I'm not getting the L. Lionel Messi. Okay. First thing we want to do, of course, is figure out the area of the whole trapezoid, Lana, using the formula for the third time today.
1/2 h times v1 plus v2
Times the quantity of v1 plus v2. You did such a great job the first two times. All right, the two bases are what lengths?
6 and 10.
6 and 10 for a sum of
16.
And the height is
7. I got 7. Didn't you?
I did too. Yeah.
Yeah.
I was like, I'm getting 6. See right there, 2. Oh, that's a 3, not a 2. 2, 3, and 2 is 7. All right, and we obviously want to take half of the 16 to get
8, and then times 7 to get 56.
So the whole thing is 56 units squared, but we have to do what with the rectangle again?
Subtract.
Subtract it out. And the rectangle is a
3 by 4.
3 by 4 for an area of
12.
12, which we subtract away to get 44 units squared. Is that what you got, Scott? All right, excellent. That rhymes. All right, so number 13, we've got a little house. It's a pentagon, right? A little house with a window. And maybe this is a real-life application, I suppose you could argue. But the problem is the house shape, that pentagon. We don't have a formula for that. So we need to first break the whole figure into two shapes. Then find the total area, then subtract out the window area, the square. So number 13 at your seats. All right, first things first, Scott. We need to take the pentagon, which we don't have an area formula for, and break it into two figures by drawing an auxiliary line where? to cut it off a triangle and rectangle. So if you draw a line right here, all of a sudden you have a triangle, you got a rectangle. Where the triangle has an area of formula. There we go. And the rectangle, of course, is simply BH. Now both of them have a base that is how long? 10. So this is going to be half of 10 times whatever, and this is going to be 10 times whatever. The height of the rectangle and the height of the triangle, 3. Of course, take half of the 10 to get, and then 5 times 3. So we've got an area of 15, and then here we've got an area of
40.
For a total area, 55. But there's the window. But you can literally count the number of boxes. It's a 2 by 2 square. We're going to subtract how many units
4.
to leave ourselves with?
51.
51 square units is correct, and that's what you got as well. Excellent. Number 14. I'm not going to have you write these out. Let me just ask these to you orally. What is a radius? Without looking back, without looking up the exact definition, what's a radius, Lana?
Half the diameter.
Well, that would force you to define a diameter also. We don't want to have to do that just yet. That's coming up in number 20. So how else could you describe a radius?
It's like a line drawn from the center to any, like, point on the circle.
Good. From the center to any point on the circle. Great job. What's a central angle, Scott?
An angle where the vertex is the center.
Sort of. Okay, so let me draw a picture here. All right. Is that a central angle?
And the lines extend to it.
So in other words, if it's formed at the center by 2 radii. There we go. Right. Has to have to be formed by 2 radii. So an angle formed at the center by 2 radii is a central angle. What's an arc, Lana?
It's like, I know I'm trying to think of how to from like the arc from one radii to another, or like.
Well, I don't even need radii. So if I start here
and there.
So it's really just any part of a circle, right? It's along the curve, right? But any part of a circle is an arc. How about a sector, Lana? Coming back to you, what is a sector?
It's the space in the angle thing. The space, like, inside the thing.
Inside the thing? What thing?
That
It's
little
like Joe
egg,
Biden now.
that-
You know, the thing. I mean, the Declaration of Independence, our most important founding document. Yeah, the thing. It's not.
No, it's the angle inside that.
Okay, so if I drew a couple radii here.
Yeah, it's the space inside of.
So it's between 2 radii and an arc? Like here? This is a sector?
Yeah.
Yes, exactly. Bounded by 2 radii and an arc is exactly correct. Or you could say a central angle and the arc, but which is what you mentioned. You mentioned the angle. Central angle and an arc. What's a semicircle? Scott gets off easy. I'm going to go to Lana. Lana, what's a semicircle?
Like half a circle.
Right, half the circle. From one end of a diameter to the other end, right? But half a circle. What's a chord, Scott?
The line that goes from one point of the circle to the circle to the another point of the circle.
Okay, so a line that starts and stops on the circle, right? What about a diameter then, Scott? Because that sounds like what a diameter does.
It's a chord that goes through the center.
Okay, it's a chord that goes through the center, and class, the circumference is simply the
Outside.
the distance
yeah,
around.
the
The distance around. 2 numbers, 22 through 24. 22 through 24. Actually, for sake of time, skip 22 through 24. Let's drop down to 25. Let's skip down to number 25. Read it for us, Lana.
A Ferris wheel built for the World's Columbian Exposition in Chicago was 250 feet in diameter. Find the circumference.
All right, at your seats. You And remember, diameter isn't just a line that goes across. It could be up and down. So in other words, that is a 250-foot tall Ferris wheel that is 25 stories. That's taller than the government building downtown. It's about as tall as the Aflac building. So that is a tall Ferris wheel. Yeah. I'm not a big heights guy. I ain't getting on the Ferris wheel. Sorry. I've been on a Ferris wheel, but never one that was that tall.
It was on at the Georgia Fair, I think.
In Perry?
Huh?
The Georgia State Fair in Perry, Georgia?
Yeah, I think so.
All right, did you get the answer, though, for the circumference of this massive Ferris wheel? What did you get, Lana?
785 feet.
Got approximately 785 feet. That's what you had as well. All right, number 26, read it, Scott.
The triangle has a base of 12 feet and a height of 8 feet. A rectangle with a height of 6 feet has the same area as the triangle. How long is the base of the rectangle?
Ah, this is interesting. We have two figures, a triangle and a rectangle, and they both have the same area. By the way, that means they're equal. They're not congruent, they're not similar, but they're equal to each other. First of all, let's find the area of the triangle. And what do we get, Scott?
84.
Ooh.
48.
48 feet, yeah, you're dyslexic. All right, so 48 feet squared would be the area of the triangle. So knowing that the rectangle also has an area of 48 feet squared, squeak fared. we're in fair mode because of the Ferris wheel, right? Squeak fared. All right, 48 feet squared. We know the rectangle has a height of 6 feet. Then the base must be 8 feet to get that area of 48 square feet. All right, your homework for this evening. Homework for this evening is to do page 245, numbers 22 through 24. Those are the three problems we just skipped. Page 245, numbers 22 through 24. Yeah, that's why it doesn't bother me if we miss. I'm like, I'll just make it homework. No big deal. All right, page 245, numbers 22 through 24 at the top. Also do the homework, 1 through 7. Also do the homework, 1 through 7. And then over on page 250, do review 25 and 26. So 2 word problems on another page I want you to do also. Page 250, review numbers 25 and 26. So one more time, page 245, 22 through 24, there's a little chart. Also the homework, 1 through 7. And 2 word problems on page 250, numbers 25 and 26. And we'll take a look at all of that in our next lesson. Have a wonderful rest of your day.